Hey everyone, we're on day 17 now today. Let's see how this is. Yesterday was quite a doozy of a problem. Oh boy, that is a very, very simple input, which is a bit worrying. Initializing debugger, 8 instructions, opcodes. Each opcode represents something. Okay, so probably part 2 will have more opcodes, or they'll do something different. The numerator is added. Okay, so we have a bunch of different opcodes that each do things. Cool. Let's initialize our stuff first then before reading on. So in this case, we have honestly, this input is so simple, I'm just going to directly copy it rather than reading from it. Int register A, was it? These could get quite big. Actually, that's already a big number, so I'm just gonna use longs. Cool. So today's input, a bit simpler. Obviously, to make it generic, you'll want to make it read in, but in this case, it's not too difficult to read in. Okay, so the first opcode performs division. All right, the numerator is the value of A. The denominator is 2 to the power of the instruction's combo operand. So an operand of 2 would divide A by 4. An operand of 5 would divide A by 2 to the B. It is truncated into an integer. Okay, so instruction point, okay, cool. This is actually very similar to the int code promise. Instruction pointer. Right, and then I assume there's going to be some exit condition, but we'll do while true for now. Int. It doesn't seem like the program can change, so I'm actually happy with this being an int. Int, what is this called? Operator equals program instruction pointer. I feel like a true Java person right now. Everything is super long-winded. Okay, I'll deal jump in a second, but that at least does that. So now we need the different cases. So I think there's 8. We'll start with 6 though, because I don't remember, and then I can add more as we go. So it says for this case, we want to, let's see, if it tries to read an opcode past the end of the program. I see, okay. So while instruction pointer less than program.length. Cool. So if it's that we have 2 to the some other register, could be quite large, so we're gonna do long numerator, I guess, first. Long denominator equals math.pow 2 to the something. Okay, wait, so we should also have the combo operator. What is that? Combo operand 0. Okay, so literal operand, that's the literal operand. And then we have combo. We'll start at 0. I'll make this an int still. Okay, so if operand. Okay, so actually we have both cases for operator and operand. So if operand less than 4, combo equals operand. if operand, oh, I shouldn't have named my thing so similarly. Oh well. So if it's 5 through 6, it's A, B, or C. Okay, and then 7 is reserved, which means it's part 2. But we'll worry about that when we get there. So B, register C. Cool. So it's 2 to the power of combo, and then where is this saved? It's written to A. Okay, so register A equals numerator divided by denominator. Actually, we could also just do 1L. I don't remember the syntax for that, but there's some way to do it that way as well. Okay, so we did 1. Now we do 2. So this is the bitwise XOR of register B and the literal operand. Okay, so register B XOR, I think it's that one, equals operand. Yeah, BST calculates the value of the combo operand mod 8 and then writes that to B. Okay, so register B equals combo modulo 8. J and Z does nothing if A is 0. Okay, so this is how we loop, right? If register A does not equal 0, that happens. It jumps to, interesting, okay. So we want to immediately jump. So instruction pointer equals operand. And we want to continue rather than keep going. Because the bitwise XOR of B and C and stores it, okay, in B. So register B XOR register C. Oh, there are indeed 8. So let's quickly do this. Okay, lots of interesting operations here. Definitely could have already done something wrong. Calculates the combo operand modulo 8, then outputs that value. Oh, interesting. So combo mod 8, and it says it's separated by commas, so I will do that. BDV works like the ADV, except the, okay, what was ADV again? Okay, and then this is still the same, the numerator is still A. Okay, so perfect. So I can just copy this into here, and then change this to B, change this to C. Okay, so let's try the example first. 2, 1, 4. Okay, that's very wrong. Where did this go wrong? If operand equals 6 is always false, how does it know that? Huh? It feels like not something that's possible for it to know. Oh, I see, because there's no 6 in there. That's fine. To do this, initialize with the given values, always run. Okay, let's start very simple then. And also let's print the registers at the end. So obviously at this point, people who are actually did it right are done. But you know, I don't think I'm that far off. Obviously that's easy to say right now, but it's no problem. I think it's at least relatively clear what's going on. So we'll do, oh right, of course this doesn't produce anything. Wait, let me just try this. Oh yeah, I'm just right. Oops, okay. You find this program is supposed to output another copy of the program. Unfortunately, the value of A has been corrupted. You'll need to find the new value to which you can initialize register A so that the program's output instructions produce an exact copy. Oh, interesting. So in this case, let's undo this. Yeah, it's nowhere close, right? Okay, nowhere close is pushing it, but yeah, it's obviously not that close. So we need to have, oh, okay, so A could be quite large then in this case. Right, and explicitly we don't know what A is. Sorry, I'm just turning everything into a list right now. Figures it might be easier to use because then I have something to check against. Right, like I can actually, rather than printing out the answer, I can return. So let's move all this to its own class. Private list integer run, and then it'll take in a program long register A. I'm just trying to keep everything as similar to above. I could use a list for here as well, but I'm gonna not for now. So we do list integer result equals new array list, and then we, rather than doing a system.print, we can do result.add. Oh, what are we adding again? Combo something? Result.add, yeah, this. Combo mod 8. Ah, that's a long, right. Okay, let's use okay. Okay. Yeah, this is mad as well, sure. A lot of type coercion here. I don't know why it's actually needed. Wait, what? Oh, okay. Let's see if this works to start. Obviously this hasn't changed anything. Oh yeah, right. We need to actually return the thing we're trying to return. Cool. I don't know why that form is a hyperlink, but that looks good. Yeah. The only thing I would do is dot replace all, any spaces with emptiness. Cool. All right, nice stuff. So we need, oh wait, what? Two, 4, 1, 7. That's not right. What's going on? That's just the answer, right? I mean, it obviously can't be. That's literally the default thing given, and I know the answer is, sorry, I know the output should be 214 or something. Why are you returning? Huh? Oh, program list should not be program list. I should be returning, equals run. Yeah, like, wow, that's crazy that the very first thing is it. I mean, obviously it's not. Cool, okay, that's good. So now, I mean, one thing we could do is just brute force it, right? But I suspect it's going to be a very large number. Having said that, I'm going to just write out the brute force way to start. Int long fake a equals 0. Also going to add a thing here. It should never take over 1,000,000 steps. And if it does, then we just break. Do lists have equals? I think it does, okay. I'm very glad today's a lot easier. Yeah, yesterday was pretty rough, but today's a Monday / Tuesday, so I guess it's not surprising. It's much easier. Oh, oops. I should be doing this inside here. And then let's just do this to keep track of progress. And when you're doing brute forces and you're not sure of how fast it's going, I think it's nice to write something in. You can also do like some power thing, like every time it doubles. Whoops, this needs to be inside the loop. Cool, so it's running relatively quickly. We'll see if it gets to an answer before I figure out what this is doing. Having said, it's a relatively simple looking thing, so I don't know, hopefully we can figure this out. Oh, it returned already, never mind. No, dang, interesting, that's not right, huh? That's a bit surprising. Result. Oh, oops, this should be program list. Oh, that's awkward. Alright, rerun. Yeah, part A is going to be wrong here, but that's fine. Okay, we're back to running. Let's start looking. So we have BST to start. BST4, and then we have, what is 1? ADV, ADV7, right? So 2417, 75. So 7 is CDV5. And then we have 50. Wait, whoops. 1, 2, 3. No, we have 0, 3. So 0 is ADV. Oh, oops, wait. 1 is BXL, not ADV. BXL. ADV 3. Okay. And then we have 4, 0. So 4 is BXC. BXC 0. 1, 7. 1 is BXL 7. And then 5, 5. So this is out 5. And then 3, 0 is JNZ 0. Okay, so the program just loops each time, right? Like that's all that this is it restarts from the beginning. So after the first cycle, it should return 2 effectively. Okay, let me just make sure I did everything right. 2, 4, so BST4, yep, 1, 7, BXL 7, okay. 7, 5 is CDV 5. 0, 3 is ADV 3. 4, 0 is BXC 0. 1, 7 is BXL 7. Then we output. Okay, cool. So now what does each of these mean? BST 4. So 4 is register A. So it takes, what is that? So B equals A mod 8. Cool. BXL 7. So 7 is B equals BX or 7. Okay, and then CDV5, CDV is like ADV except with C. So it's, okay, 5 by the way is register B. So C equals A divided by 2 to the register, to whatever the value of register B is. Okay, and then what's the next one? Sorry, ADV3. So that's A is, so 3 is just 3, so it's A divided by 8. And then BXC0, so that's just, what is this? B equals BX or C. BXL 7. So BX or 7. And then we output register C. Okay. And then we jump. Interesting. So actually we know the rough range of A, because A is divided by 8 each time, and the output is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So roughly the value of A is 8 to the 16th, which is, okay, way too big. We're gonna stop the program. Cool. So what we want to do is basically find out BXL 7 actually does nothing because it sets it after it's already done. Actually, I'm going to just write it out. So this is BST4, BXL7, CDV5, ADV3, BXC0, BXL7 out 5, JNZ0. Cool. So how would we go backwards from this, right? I guess is the key. Since we have this program list, at each stage we want to output a certain number. So that number is, let's see, it's CDV, I think. Oh, interesting. Wait, I think I might be misunderstanding. So BXC is stored in B. It's like I'm trying to figure out what the point of the last few instructions are, right? Because BXC is stored in B, but then B is immediately set with BST, right? So I don't think that matters. And then BXL, again, stored in B, but then we immediately don't care. Unless, oh wait, it outputs 5. That's B, sorry. It doesn't output register C, it outputs register B. That's why it matters. Okay. So basically, what does XOR 7 do? Well, 7 is 1, 1, 1. Right, so if they're the same, let's see, if it's 1, it'll go to 0. So it's like a knot on each digit, which means that 0 would become 7, 1 would become 6, 2 would become 1, 0, 1, which is 5. Okay, so I think it just does 7 minus the number. That's kind of all it does. So if we look at this, we effectively, to turn this into some English, right, we have B equals A mod 8, then B equals 7 minus B, and then we have C equals A divided by 2 to the B, B, A divide equal 8, B equal B XOR C, B equals 7 minus B, output B. Okay. I guess the tricky part is B equals B mod C. That's a bit tricky to think through. Because like B right now is always between 1 and 0 and 7, always between 0 and 7. This won't change it being between 0 and 7, but this might change it being between 0 and 7. Right, because this could theoretically be of any size. Let me just open an XOR chart. So 0 will always keep it the same. Okay, so the input of 0 will not change. Well then shouldn't C be quite large? Because again, we're starting with A roughly in the range of 8 to the 16th or something like that. Am I misunderstanding something? Because B is small, right? B is some tiny number, so B, X, or C could be quite large. I guess we can also we can check this, right? We can see the size of register B. Right, it's actually quite a large number. But somehow this large number... Oh, it doesn't matter, right? Because when you output, you only output the last 3 digits. 3 digits mod in binary, obviously. Okay, so sorry, it should be output B mod 8. That should be what it is. Okay. So we can sort of work backwards, I guess, to get what b is at each stage. Yeah, okay, so let's actually start that. So we'll make a reverse list because we want to go backwards, right? Equals new array list, and then we can do reverse list, reverse dot add all program lists, and then reverse dot reverse, no, collections dot reverse. Dot reverse reversed. Cool. This does it in place, right? Linear time. Cool. All right. Like it doesn't return anything. Yeah, it's a void. Okay, cool. Java docs are incredibly useful. That's one of the main reasons I choose to use something like IntelliJ over Vim. I know a lot of the fast people do use Vim. Okay. So basically, long. So at the very start, right, we have some zero. Well, we have some number, right? So we know that we want b oh, interesting. So we only care about the last 3 digits of a. Oh, this is quite tricky because a could be quite large. Like I think the tough step is this one, right? Like that's a serious wild card for C. Could be really a lot of things. Yeah, it really could be very, very many things. Because B could be a lot of things. Okay, in any case, so we start with, let's set long b equals r to start. All right, obviously it could be some 8 above, like some multiple of 8 above, but like I don't think we worry about those digits right now. We then do b equals 7 minus b, right, to get this one done. Then b equals b modulo c. That one's pretty tricky. Yeah, that one is quite difficult. Yeah, I guess this one's also very hard because we don't know C that well, right? Yeah, like at the end of the day, this ordering, right? The only things that matter, this is only used here, and this comes before here effectively, could be, is like equivalent. Right, so actually this could even be all the way at the end, like it's just, it doesn't matter the exact placement of that. So the meat of the logic is this part. We take some, oh actually I just realized I'm using both, let's do math.2 comma b just to not be confusing. So all the exponent symbols are XORs. Yeah, like this stage is the one that's very difficult to reverse. At least for me, I'm not thinking of an obvious way to reverse that. Maybe there is something obvious. But okay, so this 7 minus b, it could just be 7 minus, again, we only care about the last few digits. Oh, well, mod 8 obviously can't be greater than 7. What am I talking about? So 7 minus a mod 8. Right, and then we do this weird XOR, and then we do b equals 7 minus b. Then we shrink down a little bit. Wow, that is confusing to me, how I can possibly back out what B should be. I mean, like, really, I could just do a mod 8 here, right? This is equivalent. But B XOR A divided by 2 to the B all mod 8 is not something that I obviously know how to do. And I mean, this is much faster, but this is still not something I can just plug and chug away. Again, the numbers are 8 to the 16th power roughly. That is just way too large to try randomly. Although, wait a second. So let's take the very first run, right? It's some A. If it fails, we can just return, right? Like, if A doesn't work. But I guess the issue is we don't know. Oh yeah, we can just do a loop then for A at each stage to see what A could be, because we know the rough size of A. Right? Like, we always know the rough size of A. So A equals 0, right? So we can do 4. Yeah, I mean, there's only 7. There's only 8 values to check. We try A plus equals. Yeah, plus equals I, right? And then, so basically this is now A at the start, right? Not A at the end. If we can do this. So long temp B equals 7 minus A mod 8, which I think is just I, because at the end we're going to do A times equals 8, and then we're going to print out A. So temp B equals, that's this part, and then we do temp B equals A divided by, so A divided by, what is this? 1 mod temp B. Sorry, not mod. That's weird. Okay, so if temp B equal B, then we break. Otherwise, we subtract back off I. Does that work? Well, it gets us a number. Ah, dang. Is it roughly of the right size? Yeah, I mean, it's vaguely in the neighborhood. Oh, it's too big. Whoops. it's quite... No, it's not that close. I mean, some of the numbers are the same. What could have gone wrong here? I mean, the fact that the first number is wrong is quite a bad sign. Right, because, yeah, just start with 0. Which admittedly actually means... Okay, wait, how about this? Oh, should this be at the beginning? Is that what's going wrong? That's a different number. It doesn't mean that it's correct, to be clear. 4, 1. Oh, this is very close now. But still not right. Like, how is the very first one already wrong? No, I do think I want this still. Is this what I just had before? Hopefully not. I mean, probably is though, right? Yeah, okay. So, the fact that there's a 0 is not good, but it's alright. Alright, let's think through what I'm doing wrong. So, actually, let's just start way simpler, right? So literally just have this. So 0 returns 0. Do I buy that? Actually, let's not mess with program. Let's make a separate thing. And let's pull from that, actually. Okay, 0. Let's try it. If register is 0, it is truly 0. Okay, so now let's have this be 3, 0. Oh, I have too many print statements. Let me delete a few of them. Uh, 24. Let's see if that's right. 0, 3. Okay, that's bad. It should not be 0, 3. It should be 3, 0, right? Let's just maybe work through the 24 case so I can see what's going wrong. So we start with 24. So that would mean B is 0. B then becomes 7. C then becomes 0, right? 2 to the 7th is quite big. A becomes 3. B becomes what? 7. X or 0 is 7. b equals 0. Yeah, okay, that does in fact result in 0. Which is quite not good. Wow, great English by me. Because we're finding the last number here. Does this mean I shouldn't be reversing? Is that what that suggests? 192? I mean, we can try 192. Feels a bit large though, right? Shouldn't that be like 3 results? 1, 0, 3? Okay, that's even worse. Yeah, maybe that's not it. Okay. But what results in 3, 0? Yeah, actually, let's just work out what would give 3, 0, right? So we have output B is 3, which means that B must have been 4 beforehand, right? So Bx or A divided by 2 to the B is 4. And the easiest way to do that is if A divided by 2 to the B is 0. But I think that's not happening, so we'll say it's 1. Then we'd need B is 5. So if B is 5 and A over 32 is 1, then we're good. And that would mean that B is 5 at this point. So A mod 8 is 2. Can we make that work? Yeah, so 32 is 34 maybe? Does this work? No, 34 results in 3, 4. Right. Okay, wait. So let's do the next one then. So next one we know returns 0. Which means, B is 0, B must have been 7. So at this point, A is between 0 and 7. So I think A would have to be 8, maybe, at the end there. So if A is 8, oh, then we're kind of doomed, eh? Because we need 64. So maybe B would have been 6 at the beginning then. 6 XOR 2 gives you 4. So if A is 6, then that would be 1, so maybe 65. No, 65 is super off. Oh, right, 65 is too big. Oh, this is really quite annoying. All right, let me go through and try some numbers just to get a feel. So is 1 through 8 just 1 through 8? 2. Yeah, I'm pretty sure it is. Which makes sense because... Actually, I don't know. Yeah, that doesn't make sense. 6 is 5. Oh, that's tricky because there could be multiple things that are 0, huh? That actually makes it quite difficult. What numbers return 0 again? So 0 does. And then 7 does, I think? Yeah, so 7, maybe like 31. What the heck? Why does that return 3 now? Oh, right. So it'd be, what is it, 63? Right, but that's 7, which is bad, so 62. Okay, I should be writing, no, it doesn't make sense to write these down, because again, the a divided by math.power thing will screw this all up. Okay, but like 60 works for this. Okay. What we could do is let's just actually take some candidates, right? So call this partial, and then we do the thing we just did, right? Let's just take in the first, I don't know, the last like few elements. Maybe actually, yeah, we can just use program list. What am I doing? So let's just do around half. Actually, I think that's exactly half that I chose. Nice. And basically do while, what's it called? Run program fake a 0 0 dot equals program list, I guess. Because this should be roughly 8 to the 8th. Oh, maybe that's even too big. How big is 8 to the 8th? Is that workable? 16 million? Yeah, that should finish fine. Actually, yeah, let's just do that instead then. Well, fake A is less than something like that if run then let's just see how many there are. I mean, we'd ideally want to store this in a list, but I'm just going to do a quick check, right? Okay, so quite a few. Let's just do a random one just to make sure, just as a sanity check. $40155. Okay, cool. This was unfortunately slightly slow though, so I'm instead actually going to do 664, which should hopefully be faster. So 6 is 2 to the 18th. Cool, yeah, that finishes pretty much instantly, which is exactly what I wanted. So I guess I could technically speed this up slightly by doing that, right? This should not lose any values. It doesn't, cool. so we now have this list of possibilities, right? So we just do the thing again. Except this time we do for long possibility in possibilities. We, oh, and our program list needs to be different. So we're doing these, so we take the next 6, 1, 2, 3, 1, 2, 3. Add in these new values. Again, we want to start at E17, saves a little bit of time. So fake A times 118 plus possibility. We want to make a separate list. Yeah, this is getting very messy. But that's fine, I think. I think we're quite close to the answer at this point. Like, I think the combinatorial explosion's under control. Oh, that's not good. It didn't even return anything. Oh, right. I still need the other elements in there. Nope, still not working. Well, that's not great, obviously. Why would this not work? I guess it could be that making A bigger has ripple effects. Yeah, that is the catch, right? Is like, I guess if you make A bigger, this could ripple. Can only ripple by a factor of 3 though, I think. Right, like it only can affect the next 3 numbers. Okay, in that case, what we could do is do, what, 7 numbers, but then only keep the last 4, and then do that 4 times, get all the numbers. That could work. Let's test that theory. So what we could do is this is 6 numbers, right? Let's go to 7, see if that's too taxing. How do I easily represent this? Because I actually only want now, so I'd do like, we remove these 3. We just have 5, 5, 3, 0, and then we want 7 more, so 1, 2, 3, 4, 5, 6, 7. We'll grab those. Actually, wait, okay, let's also just print out fake A again. Also specifically, I'm curious about fake A mod 2 to the 12th. Like, is it all the same? Whoa. It's a lot of values. What is going on? Oh, wait, what? 1,000. Yeah, 2 to the 12th is tiny. What are all these numbers? Is that from here? No. Huh? Do I have other print statements? Oh, I'm doing print. Oh my goodness. I did a print instead of a print line, so they all concatenated. That's why it looks so massive. Okay. Oh boy, no, these are all sorts of different. Yikes. Okay. How do I deal with that? Oh, that's so bad, no? Zero 1 7 5 5 3 0, yeah. No, it's not returning anything. So maybe my hypothesis is wrong. We can't just look at the last 3 digits. Also, I'm curious, how's the leaderboard panning out? Oh wow, it only just filled up a little bit ago. That's quite a difficult one. Probably the longest leaderboard, I think, so far then. I can't think of any other cases where the leaderboard took 40 minutes. But yeah, interesting. Okay. I feel like I'm getting somewhat close, but I'm not quite seeing why this doesn't, like, A divide, oh, math.pow b could be variable as well. Oof. Okay. Yeah, that's tricky. I do wonder how much I could stretch this to. Like, this worked, right? Yeah, I mean, it's not fast, but it returns stuff. But I'm still way off from actually getting it, right? Because there's so many more digits left. Oh, maybe I should just start with these digits then. Not that many. Let's start with this, like the first ones. Wait, there's no answers? Huh? There's nothing that yields this sequence. Well, now that's pretty nuts, no? Oh, yeah, that's actually quite possible because of how A works, right? Like A is so much smaller here than the numbers it's expecting. Yeah, the fact that this is divided by the pound is so hard to think through. It's so hard to think through. Wow, my brain kind of hurts trying to process how to think through that. Okay, new plan. Let's just look at how it evolves throughout the numbers, right? Yeah, let's ignore all of this nonsense. All right, so it's a bunch of values, all in a relatively tight band. What is this band, by the way? It's okay, so it's all in the like 7 times 8 to the 3rd range. Okay, and if we look at then, say, 2 more numbers. Actually, I'm just going to write these down without this. There's not that many. Oh, okay, there's 6. Interesting. So there's 6 for this, and then if we added 4 comma 0, there's more, right? I guess it's not too surprising. 1, 5, 4. But yeah, let's actually do this again, but yeah. Just see if any of the values match, right, between them. No, not in the slightest. Huh. In fact, it's kind of nuts, right? These are all roughly in the range of 8 to the 8th, right? And yet, so 8 to the 8th is 2 to the 24th. Yet these numbers are absolutely tiny, right? Like, okay, what if we removed a digit? Yeah, these are all relatively small. I guess 3,000 is not that small. Okay, never mind. That's the theory is kind of falling apart there. Yeah, I mean, all these numbers are roughly what, 1, 9. Like, what is this? They're all pretty big, right? That's what I've noticed is like the numbers stay relatively big. It's almost always 7 times something. I'm actually going to try to push the limits here just to get one more data point. So the last 9 numbers, this will take a very long time because each iteration we're doing 8 times the amount of search space, and the function has to run for longer as well, right? So this is not trivial in the slightest. But like again, this number is just, I'm pretty sure it's roughly, yeah, it's roughly 8 to the 9th. It seems to always start with a 7 in base 8, if you imagine. Why is that the case? I mean, this does roughly mean I know the scale of the actual final number, right? It'll be somewhere in the 2e, yeah, 2.4 to 2.8 E14 range, but that's not the most helpful. That's unfortunately still too big for this. Like right now, these numbers are rough. I'm doing roughly 2 to the 26th calculations, whereas for if I did all of it, I need to do 2 to the 47. Even the more optimized solution would be like if I could assume 7, it'd be 2 to the 44th, which is still too big. Maybe I'm looking at it the wrong way. What about I do divide? Like maybe the first numbers have some pattern? Maybe I should have done this with the smaller ones to start. $30,081. No, I mean that's just some random number, right? Like 30,081 base 8. No. 2 base 8. It's like 72601. Yeah, that's nothing special, I don't think. I guess I'll write them down though. Maybe the number comes back up somewhere. Was it 30,081, 30,129, 31,153? Okay. Let's go next set. Uh, 3760, 3766, 3894. Oh, I should be doing like something like minus 8, I guess. Should always get us 8 digits. Yeah, for consistency. 235 and 243. 235, 241, 243. Now that's interesting. $235, 241, 243. Oh, okay. That's quite interesting, right? So the first 3 digits now we have some idea of. Now the question is, are those digits the answers to the smaller ones, the smaller problems, right? 235, 243. Yeah, in fact, that's okay. So we have the first 3 numbers. It's okay. It's actually quite good. But let me just check one second. What is the actual? Yeah, I guess whatever. We can keep that in there. Like, is it 240? Oops, one more. I swear I know how to do basic math. Why did I choose 8, by the way? Yeah, 8 is such a stupid number to choose for this. Let's choose 12. And then yeah, let's go back to this. Because the thing is, 8 is not a power of 8. So it's kind of a nonsense thing to choose. Okay. So what is this? 3760, 3766, 3865, 3889, 3894. Okay, and now if we add a digit, um, 376066, 3865, 38. Yep. Okay, the same ones. And now if we add another one, three seven six zero, 3766, 3894. Oh, interesting. So two of them have died out at this point. Okay, now we do one more. Okay, but I'm quite confident actually. So the last numbers actually influence the first numbers, not the other way around. Like the last numbers don't influence the last numbers of a given number. Which is actually quite interesting. I don't know why that holds, to be totally honest. Yeah, look, it's the same thing. Like all these numbers start with 3894. Okay. So what we could do is just use these numbers, right? Like all the numbers we have stored, make a new program that's... Oh, it's still going. Yeah, okay, look. This is too long. Let's get rid of you. Program 2 is this. Right, so then we do... let's uncomment this. We do possibility times this plus fake A. Did I just delete this exact line that I'm now writing in? That's kind of funny if I did. Okay, that's the first wave. See if I did this right. I think it's the right amount over. Ugh, maybe I should do even fewer digits. Yeah, because this is actually a lot to do. Yeah, maybe this is a bit overkill. Fake A. And there's not that many possibilities, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, but I guess running the program takes sort of asymptotically more time. Oh, actually, we're not going to hit this limit, right? No, because counter is... So it'll run... How many times it'll run? There's 1, 2... So there's 16 instructions, and it runs 16 times. So every program should finish within, like, under 300 instructions. Oh, interesting. No results, huh? Okay. I mean, seems like I may have done something wrong. Which is definitely not out of question. Maybe we go a little easy on ourselves and just remove one from each of these. Also, maybe we just start at 0 instead. Yeah, we print out a bunch of things. So these should all be the, like, potential headings for the future. My goodness, there's so many values. What are these values? Oh no, I should not be printing this. I should be printing out this. Okay, but I think conceptually this works, right? I mean, it's taking a while, don't get me wrong. But like, yeah, let's just try this number, for example. Oops. Oof, that's a lot of values. So this is 2 to the 14th, by the way. This is printing out 14 numbers. Let's see if it's right. 4177503. No, 03. It's missing this 4. Why is it missing that 4? Oh, because I took, yeah, okay. No, this is correct. So I think if I add these back in, it should eventually return the right answer. I mean, it'll be slow as balls, but I think it should work. Also, actually, we can just break after we find 1, because we just need the smallest one. But yeah, this is gonna take a while. I mean, yeah. Well, I mean, these are some massive numbers that has to chew through. Because I guess let's think about what adds time complexity here, right? So obviously we have the first iteration, let's say, takes 1 second, and now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of these. Oh, hey, that's a number. Let's try it out. I'm confident my approach is right. I'm not confident the specific number is right. Oh, it is. Nice. Yeah, I'll try to clean this up a bit. It's kind of a disaster currently, but I think my overall approach did make sense, right? Like, try to figure out what this program actually does. See if there's what patterns result. In this case, it turns out that the back end numbers will give you some possible output, and that possible output is the only possibility for the first n numbers of the actual resulting program. Again, I don't really understand how that works, but apparently, oh, it does make sense, right? Because it's, no, actually I have no idea why it works. Like, why would the first number be, yeah, you know, I'm not sure. But yeah, see you guys tomorrow. I think one of my better results today, even though it did take a while.